Okay, so linear activation basically, yes, Camilla. Okay, sure. Okay, right. So now this linear activation is basically what we discussed, and the output layer of regression problem, you have like use the linear activation. And another thing, now last time, unfortunately, due to a connection lost, our class like stopped middle of the three hours. So, but we quickly restart, but I forgot to record the session, right? I forgot to record the session on the second, actually the second session, right? The second half of the session after the breakdown. So what I did was I recorded it again, right? I mean, that's not the live session that I conducted, but I recorded it separately, right? And I uploaded it. So you can view the part two. So that's not the live thing that we covered, but it's a separately recorded thing. But please go through that second part. I was talking about thing that I didn't mention in the live class, the use of the activation function. So how to like choose linear or non-linear activation function, why we are using some activation function to map the features and labels. So we are going to match features and label, I mean X and Y. So that's the task of the activation function. So I described it in detail. So please, I'm like not the first part. First part is the same thing that we covered in the live session, but second part I have uploaded separately, separately recorded thing. So please go through that thing. I have like mentioned few new things, right? So please go through the second part of the session on the last Saturday. Okay, so the activation functions we discussed, and then thereafter we talk about the loss function. So mainly we have like two main types of loss functions. Uh, the mean squared error, this is used for regression problems, and cross entropy loss used for classification problem. And as I mentioned, these are not only the main type, and these are not the only loss functions available, but these are the main loss functions available, main types of loss functions. So like the thing is now uh, we have like some modified advanced versions of these loss functions, right? So these are the fundamental type of loss functions. Uh, okay, so we have a question. When you are done with recap, can you please explain a little bit what's the tensor? Of course, I'm having yes. Okay, what's the tensor? I will explain that. Okay, so then loss optimization. We discussed the gradient descent algorithm, and after that we discussed about the learning rate, the importance of learning rate, right? So we had like start with a big learning rate, and eventually when we are like coming to the convergence, we have to minimize the learning rate, right? Reduce the learning rate. So these things are included in the previous video, so please go through. And keeping a track on the learning rate is important, since like I mean yes, so like keeping a track is important, since we can, I mean I will show you that we can get these kind of graphs, right? These kind of graphs. So so we can then see if this is if our neural network is not converging. So what do you mean by converging? Reaching to the minimum loss, right? So if our neural network is not converging, there might be an issue with the learning rate or the activation function. So we have like see, and we have like rectify the issue we are having, right? So in that case, these things are quite important. So that's why I covered these things in detail on last few weeks. So then we have like adaptive optimizers. So having an adaptive optimizer is basically what do you mean like adaptive optimizers? Now the basic optimizer is the gradient descent algorithm, right? This stochastic gradient descent algorithm is the basic what you call the optimizer, right? The fundamental optimizer. But from that we have some adaptive optimizers, which are like modified, advanced version of the gradient descent algorithm. Now the use of advanced or the adaptive optimizer is we have like basically the advantage of uh, auto-adjusting learning rates, right? Like so, inside the neural network, it's going to adjust the learning rates according to the situation, or according to according to the instant, according to where the current error is, right? So it's going to analyze the situation and adjust the learning rate accordingly to if efficiently reach the convergence point, right? Convergence point එකට යන්න learning rate එක automatically adjust කරගන්න පුළුවන් මෙන්න මේ adaptive optimizers වලට. ඒ කට්ටිය මුල් ටිකේදී ලොකු يعني තැන බලලා එයා ඉන්න තැන බලලා loss එක තියෙන තැන බලලා ඒකට අදාළව learning rate එක adjust කරගන්න පුළුවන් මේ adaptive optimizers වලට. උදාහරණයක් විදිහට we have several, for example we have like several adaptive optimizers, adaptive momentum, this is the long term is adaptive momentum, adaptive delta, adaptive gradient. So we have several optimizers available, right? So now we are not using gradient descent or stochastic gradient descent that much, but we are using these advanced optimizers in our implementation since they are very efficient in converging compared to the gradient descent algorithm, right? So keep this point in mind. Now, and adaptive delta, adaptive gradient. So those are like have the capability of adjusting the learning rate according to the situation, according to the according to the loss, current loss, right? ඒ කියන්නේ උදාහරණයක් විදිහට මෙන්න මේ දැන් ඉන්න graph එකේ ඉන්න තැන දිහා බලලා, right? Right. Right. මෙයා දැන් ඉන්න තැන දිහා බලලා, right? මෙතනදී ඉන්නේ මේ හරිය වගේ තැනකදී ඉන්නේ මේ වගේ තැනක, right? ඒ තැන දිහා බලලා learning rate adjust කරගන්න පුළුවන් මේ adaptive optimizers වලට. ඒකින්ද ඒ කට්ටියන්ට බොහොම efficiently convergence point වලට reach කරන්න පුළුවන්, right? I mean, we can prove this with right, some evidences, right? I will show you in the codes. Okay. Yes. So these are the adaptive optimizers I was talking about, right? So today we have talked about the backpropagation algorithm. So what you simply mean by backpropagation? This term, right? So this term, right? Now, if you have this term, that this is the gradient, right? So this is known as the gradient, right? So the gradient, we are going to like decide two things from this gradient, right? So whether it's positive or negative, we are going to add, we are going to like increase the weight or decrease the weight adjustment, the sign of the weight adjustment, right? And also the magnitude of the weight adjustment, right? The magnitude of the weight adjustment, right? So I was talking about these things in last few weeks, right? So the gradient is basically giving us the sign, that means whether we need to increase or decrease the weight, right? And the magnitude of the magnitude of the weight increment or decrement, right? So those things, those two things are dependent on this gradient, right? It's dependent on this gradient. So in order to calculate, now if you have this gradient, it's simple. The gradient descent algorithm is going to do nothing. Weight minus learning rate into this gradient, right? So that's simply the adjustment, right? So that's simply the adjustment. Now this adjustment, another thing that the thing is, now this adjustment, this gradient is given to you by the backpropagation algorithm. So the important part in gradient descent is done by the backpropagation algorithm, right? So backpropagation algorithm calculates these gradients and give it to the gradient descent algorithm. Gradient descent algorithm is going to apply it to the gradient descent algorithm or whatever this thing, this equation, and measure the weight adjustment and do the weight adjustment for each and every trainable parameter in the neural network. Neural network එකේ තියෙන හැම trainable parameter එකටම individually මෙන්න මේ weight adjustment එක කරනවා. මේ weight adjustment එක කළාට පස්සේ ඒ gradient එක ආවට පස්සේ තමයි gradient descent algorithm එකට මේ weight adjustment එක කරන්න පුළුවන්. Right? Understood. So important thing, backpropagation algorithm is one of the important thing that you need to like have. I mean, you can implement neural networks without anything, right? Without any theory, you can implement the neural network, right? So that's like few lines of a code. But the importance here that you need to have like the knowledge. Otherwise, there will be no capability of like I mean customizing neural network, like debugging or error correction. You can't do those things, right? So you can't optimize neural networks besides the theories, right? Without the theories. So that's why we are focusing more on those things, right? I mean, after today, like, so there will be a bit relief since the theory parts will be not this much hard, right? So the fundamental thing, the foundation, that's the most like complicated thing we have to do. Like, so within the last 2 weeks we covered everything, so this is like a bit relief since on next week onwards we have like go through smoothly, not like big theories like this. Okay, right. And okay, so going back to the coming to the backpropagation algorithm, right? So I took this example from the internet, and I will probably mention the source as well in your website, right? In the edXop website, I will mention the source as well. So in to implement this one, I will I mean to make you understand the backpropagation algorithm, I will basically implement a small neural network and implement few equations and show you, right? Okay, so let's assume now you know what's backpropagation. Backpropagation algorithm calculates the gradients and give it to the gradient descent algorithm to update the weights, right? So that's what the backpropagation algorithm does. Okay, so let's take a simple neural network, right? Let's take a simple neural network. Now some of the times I'm forgetting to record the session, right? So in that case please see now, if the session is recording, you can see the recording button, right? So if it's not, please quickly inform me, otherwise the session will be missed and I need to like record it again. Okay, right? So yes, so this is a simple neural network, right? Where we have like this kind of a architecture, a simple architecture, right? Okay, and please give me a second. Okay. Yes. So yeah. Okay. Yeah. Okay. Right. So this is the neural network architecture, right? Neural network architecture, simple neural network. Let's say we have like two features and two labels, right? So these are the x1 and x2 values. So quickly I will, yeah, x1, x2, y1 and y2, right? And let's assume that this is having like biases b1, b2, b3 and b4, right? And weights, so there are like few weights here. I will mention those things in these two, in between these w1 to w4, right? So we have like w1 to 4, 1, 1, 2, 3, 4, right? So you can see four weights are there, and also here w5 to 8, w5 to 8 here, right? So we have like 8 weights, 4 biases, right? Right. And let me like write some values for these things, right? Let me write some values for these basically. So let's say x1. Uh, I'm just assuming some values, right? X1 is 0.05 and x2 is, I'm just putting some default values, right? For input values x1 and x2, and also like then we have to include the b1, b2 and b3, right? So b1, b2, I'm going to put like b1 and b2, let's put 0.35, yes, 0.35, and for b2 again the same value, let's say, I mean, not no need to be the same value, but I'm for to make the calculations easy, I'm going to put the same value, right? Okay, right. So then the weights, let's have some default values. Weight 1 equal 0.15. These are like totally random values. You know the weight, uh, they are random values at the initialization. So weight 2 is, let's say, 0.2. Weight 3 equal 0.25, right? I mean just random values, 0.3, and also, yeah, so here w5 is equals to 0.4, w6 0.45, w7 equal 0.5, and w8 equals like 0.55, right? So I just got some random values to the weights and biases, that's all, right? Let me, yeah, okay, so that's it. So we have like a neural network which takes two inputs and gives two outputs, and the weights and biases were initialized randomly. That's all up to now, right? So then let me like uh, assume that sigmoid activation is there, right? Sigmoid activation in here and also here. Sigmoid activation in both layers, right? Hidden layer 1 and hidden layer 2. So no activation functions in the input layer, you know, right? Input layer activation functions දාලා වැඩක් නැහැ. මොකද ඒකට inputs එන්නේ නැහැ නේ කොහෙන්වත්, output එක විතරනේ යන්නේ. ඒතර මෙතන දාන value එක තමයි හැම වෙලේම output එක විදියට යන්නේ. Right? Okay. Uh, yes. Yes, okay. We had a question, right? So about the tensor. I think it's better if you can. Uh, I will explain it with the code, right? So we are using tensors. I will explain it there. Okay, about the tensors. Okay, now coming back to this one. Yeah. So what we can do is that. Okay. So let me. Yes, let me like. Uh, Name these things: h1, h2, y1 and y2. Okay, so now I can write directly, I can write the equation to uh, like the value of h1, right? So H1, you know, F into sigma Wi xi plus b. I'm talking about this neuron, right? So we can write it like what? Uh, let me write, yeah, right? H1, yes, can someone? Yes, H1 is equals to what? Now, let's assume that, okay, so this is W1, right? And this is W2, right? And this is W3 and this is W4. W1, W2, W3, W4. So can you give me the equation here quickly? Let me write without the F. Yes, quickly. Easy, right? X1, W1, X2, W2 plus. Yes, 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 good. V1. So I will write the output y h1. That means the output of this neuron, right? Output of this neuron will be equals to what? Yes, it will be equals to sigmoid 1 over e minus h1, right? So this is something that you know, right? Simple. Okay, right? So similarly, I can write equations, right? I can write equations. I can write equations to these, this, this, and this, right? You know, right? So I can write directly equations to those things. I can keep writing these things, right? So I can then find the value of this one, h1. Let's say h1 will be equal to, depending on our values, right? Depending on our values, let's say h1 equals to, yeah, x1. So x1 is what? X1 is equal to 0.05, right? So I can get the numerical value 0.05 into 1.5 plus 0.1 into 0.2, the weight value 0.2 plus the bias value, it's 0.35 B1, right? Right? Okay. So then I can get the value for this, right? I can get the value for this. So it will be, I have calculated this, so 3 point, this one, right? And I can apply this value to this equation and get the activate to, I can apply it to the activation function and get the this value. So it will be basically 1 over 1 plus e minus 0.377. So you are going to get a value like 0.5933. So now I'm talking about here the forward propagation, right? So I'm talking about the forward propagation here, right? So this is the forward propagation. So similarly, what I can do, I can write the same equation similarly to this neuron and get the output of that, right? So you can do these things, but I'm going to directly get the answer. You can do this similar procedure follow කරලා ඔයාලට ගන්න පුළුවන් YH2 වලත් මේ විදිහටම value එක, right? YH2. So Yeah, it will be like something 5.969, right? Yes, so then what we can do, uh, then I can calculate, yeah. So then similarly, I can calculate this value, right? This value. Uh, yeah, so let me write it as Z1, right? So Z1. Uh, so calculating Y1 and Y2, right? Yes, calculating Y1 and Y2. So y and calculating y1 y2, simply I can write it as y is equals to the in terms of z, yh1 into w5, yh2 into w2, sorry, w6 plus b2, right? So you can see it's simply, right, whatever the value coming here, yh1 into w5, yh2 into w6 plus b3, right? So I'm talking about this neuron. Yes, we have, yeah, it should be it should be b3, right? Sorry, it should be b3, right? B3. And so we can get the values like, note that I didn't apply this into the activation function yet, right? I'm just getting value, the z value, 0.5933, 0. Yes, 0.5969 into 0.45, right? Plus the bias value, and you are going to end up with the value like 1.106, right? Then we can calculate y1 output of the y1. We have like apply this value 1 plus e minus y1, right? So you are going to end up with a value like 0.75, right? 0.75. So similarly, doing similar thing, you can calculate y2 as well, right? So you can calculate similarly y2 out. Y2 out can be calculated using a similar approach. So it will be like 0.77. So you have like leisurely do this calculations, right? So you can calculate it. This value also can be calculated, right? Okay. Okay. Now, okay. So that's it, right? Now, what we need. Okay. Now let's say y1 actual is, let's assume 0.01, and y2 actual, let's assume like 0.99, right? These are actual values, right? So we have the predicted values, right? We have the actual values, we have the prediction values, right? Assume these are the actual values. Now what we have to do, right? So I mean, we have repeatedly discussed about these things. So now what we have to do, we have to calculate the error, right? Error. So we can calculate the error. Let's say the mean squared error, we are going to focus on mean squared error, right? So calculating the error. So error will be basically error total, let's say error total is equals to sigma half y actual minus y predicted square, right? Since we have two neurons, right? So this will be the error, right? Understood. Okay. So now what we can do, we can write this error and we can get the error, right? Yes. So error total, let me get the error total, will be equals to like half 0.01 minus 0.713 squared plus 0.99 the actual value minus the predicted value 0.077, right? And I think those were the 77 and 75, right? 77 and 75 were the predicted values, right? And the actual values like 0.1 and 0.99. Okay, so then what we need to do now, we have the error, right? So this is something that we already know. So we have the error. Now we need to, depending on the error, we need to like adjust the weight, right? Adjust the weight, and we need to do it like, right? We need to adjust the weight, and we have to calculate the weight adjustment. So weight adjustment is done by the gradient descent algorithm. So let's say, okay, updating. Okay, so let's consider weight 5, right? Weight 5. So what we already know, right? Weight 5 will be weight 5 old learning rate right? So this is the gradient descent algorithm, right? So this is what you get from the gradient descent algorithm, right? So if you know this thing, this term, learning rate is, I mean, that's something we can later, like learning rate is something that we are going to define. It's a constant value. It's going to change, but we can define it. So now we need to find this one. So this one will be given by the backpropagation algorithm, right? Okay, so how we are going to obtain it? Now we need to like, okay, so do we have the error now? Right. So I will write again the error. Error total will be half y1 actual minus y1 predicted squared plus half y2 actual minus y2 predicted. Okay, now we need to find this term daba et over daba w5, right? So this is like differentiation, right? So this is differentiation, to be exact, partial derivative, right? We have like partial, we have to implement the partial, I mean, no need to have the maths knowledge. We have to get the we have to differentiate it, right? Right. Now the basic rule of differentiation, right, is that in the equation of et there should be w5 term, right? There should be w5 term. So can you see a w5 term? W5 තියනවාද මේ et එක ඇතුලේ? ET එකතුලේ W5 කියලා term එකක් තියෙනවා. ඒ කියන්නේ for example, right? So let's say y equal to 2x plus 5x squared 3 කියලා. So then we can get dy dx. Since x is there, right? X is there. Now, can you see a term directly? I'm asking, like, can you see a direct term of W5 in ET? Yes. W5 තියනවාද ET ඇතුලේ? ඇතුලේ තියෙන්න පුළුවන් ඔය predicted කියන එක ඇතුලේ, right? තව ඇතුලේ තියෙන්න පුළුවන්, right? But directly මෙතන නෑ නේද? මෙතන directly නෑ ඒක. Right? So you can't find that directly. I mean, W5 term is not there directly, right? So you can't find a term directly here, right? So the solution is that we have in calculus, we have something called chain rule. දැන් ඇයි මේක හරියන්නේ නැත්නම් මොකද W5 term එකක් කෙලින්ම මේ equation එකේ නෑ. එහෙම දැන් මේ වගේ y equal 2x ධන 5x වර්ගය ධන 3 මේ වගේ එකනම් කෙලින්ම dy dx ගන්න පුළුවන් අපිට gradient එක. මොකද y කියන equation එක ඇතුලේ x තියෙන හින්දා. හැබැයි මෙතන අපි ගන්න යන්නේ et over w5. හැබැයි w5 term එකක් මෙතන නෑ. No w5 term here, right? So we can't directly apply the partial derivatives here, right? So what you can do, we have a solution for this, right? Right? In calculus, we have something called the chain rule, right? The chain rule. Chain rule, right? So in chain rule, what it says that we can write, okay, now we need DABA ET over DABA W5. So we need this thing, right? So instead of directly finding this term, what we can do, we can apply the chain rule, right? So we can write it as a chain like this. DABA E total over let me see, yeah, y1 out, right? Y1 out into DABA y1 out into DABA y1 into DABA y1, right? DABA w5. So instead of getting it directly, we can like get it from 3 terms, right? So in theory, like, I mean, this is not the actual thing, but like we can, I mean, we can see, right? So can you see now? මෙහෙම වෙන්නේ නැහැ. මම මේ කියන්නේ මෙහෙම කරන්නේ නැහැ නේද? idea කියන්නේ මම කියන්නේ මේ දෙකම එකයි කියලා වගේ පෙන්නන්න. මේක වැරදි මෙහෙම කළොත්. So this can be cancelled off with this one. This can be cancelled off with this one. So ultimately you are going to get the same thing. See? But we can't do that, right? So that's, I mean, just I told you like that kind of thing. That's not the theory, right? එහෙම කරන්න බෑ ඇත්තටම, right? But we can, I mean, instead of find that directly, using the chain rule in calculus, we can get the thing using 3 terms. මේ තුන ගුණ කරලා අපිට ගන්න පුළුවන් අවසාන අපිට ඕන දෙක. මොකද නම් මෙහෙම කියන්නේ these things can be taken. මේවා ගන්න පුළුවන්. මේ වගේ directly සම්බන්ධයක් තියෙනවා අපි බලමු. Right? Okay, so first we will take this term. Well, so this is first one, this is second one, and this is third one. Let's see how we can analyze this thing, right? Okay, so the first one. Okay, Can we write the equation? Yes. Let's say Et equals, we know this, half into y1 actual minus y1 out. Half y1, sorry, y2 actual minus y2 out, right? So what we can do now, we are now going to get E daba Et over daba W5. Not that, but we are going to get daba Et daba E out. So can you see now? E, now can we get this thing? I mean, daba Et over daba, yes, what we need, out, one out. So can you see now? This term is there, right? That means we can apply this. I mean, we can differentiate it, right? So we can get the derivative, right? So I'm not going to talk about the calculus here, but this can be done. So what we are going to get here is basically 2 into this one. And then මේ calculus differentiate දාපුවාම මෙන්න මේ වගේ තමයි එන්නේ. Differentiation දාපුවාම මෙතනට derivative එක ගත්තාම y1 actual minus y1 out into -1 මේ කැලල අයින් වෙලා යනවා +0 ඒ කැලල වෙන්නේ නැහැ. So it will be basically minus y1a minus y out 1. That's all, right? So this will be equals to what? This will be equals to, now y1 actually is 0.01. The actual value I wrote it earlier, and this will be 0.75, right? So the value will be 0.74. Now this term is calculated. Now we have to go to the second term. Let's see that whether we can calculate the second term as well. So in the second term we have like y out within 1. Yeah, okay. So now we know y1 out. Yeah, y1 out is equals to 1 over 1 plus e minus 1 නේද? අර y1 ගන්න මෙහෙමනේ. මේ equation එක දාලා අපි y1 ගත්තේ. y1 out එක. Can you remember? Yes, can you remember here? Right? Okay, so the same thing here. Now that means, okay, now what we are going to do, now we are going to get daba y1 out divided by daba y1, right? Okay, so then මේ differentiation කරන හැටි මම කියන්න යන්නේ නැහැ, මොකද අපිට ඒක කරන්න ගියොත් වෙනම maths පාඩමක් වෙනවා, දවස් දෙක තුනක maths පාඩමක්. හරි, මම කියන දැන් මේක අවකලනය කළාම answer එක මොකක්ද කියලා. So we are going to like differentiate this and get the answer. So it will be basically 1 over the same thing as here minus 1 over 1 plus e. And making අපිට මේක අවකලනය කරන්න, can we differentiate this? Yes, y1 is there in this one, this equation, right? So we can differentiate it. So similarly we can differentiate it. So this will be like we know this value, right? So this value is calculated. This value is calculated earlier. So it's 0.75, right? So it will be 0.75. So simply 0.75 into 1 minus 0.75. So that will be 0.1868. Yeah, 1868. Right, so 1868. Okay, right. So with that, we have this term as well, right? So we have this term as well. May term में तभी calculate करा. Okay, so similarly we have to calculate this term y1 w5. Yes, so it can be calculated. So we know the equation for y1, right? So what's the equation for y1? Yh1 into w5, yh2 into w6 plus b. This one, right? So y1 will be this, right? So now what we have to do, we have to calculate DABA y1 over DABA w5. Can we do this? Yes, can you see w5 is here? So if w5 is here, we can get the derivative, right? So the derivative simply will be uh, yes. So it will be basically uh, yes. YH1, right? It will be basically YH1, only YH1. So YH1 is we have calculated the YH1. Yeah, 0.5969. Sorry, YH1 is this one, 5933, right? 5933, right? So it will be 5933, right? So that means we have the third term as well, right? So now we can directly get by multiplying those things, we can get W E by E total divided by W5 by right. So we have to multiply the values 0.74, 0.18, 0.59, and you are going to end up with like the value between 0.82. Sorry, right? It should be like 0.08 to 1, right? Okay, so this is this term, right? So now what we have to do, weight 5 minus daba e total daba w5, right? Understood. Now we are talking about, I will just quickly. Right. So we calculate the weight adjustment of W5, right? W5. So similarly, ඔය වගේම ඔය විදිහටම W6, W7, W8 අපිට calculate කරන්න පුළුවන් ඔය equations ම use කරලා. right? මෙතන වෙනස් කරන්න තියෙන්නේ මේක විතරයි. Sorry, this should be like 5, right? Right. ඔය විදිහටම similarly, using similar equations, we can calculate, right? Right. And also using similar method, like 5, 6 calculate කරන්න පුළුවන් y1 out use කරලා, y1 use කරලා. What's the reason? Now can you see in y1 you have, right? y1, can you see in y1 you have 5 and 6, right? 5 and 6, wait, 5 and 6 terms are there in y1. So you can't use y1 to calculate, what do you mean, like 7 and 8. In order to calculate 7 and 8, you have to use y2. Since you can see the y2 is connected here, right, to weight 7 and weight 8, right? So similarly, what you can do, like we can calculate 7 and 8 using this. මොකද දැන් මම කියන දේ නේද 7 කියන එකට y1 ගේ අදාළත්වයක් නැහැ y1 ට 7 එන්නේ නැහැ weight 7 අදාළත්වයක් නැහැ එහෙනම් මෙතන 2 ගෙන් තමයි ඒක හොයාගන්න ඕනේ right so similarly using another equation we can calculate the weight adjustment here for w8 as well right? Okay, so using that we can calculate w5 6 7 8 weight adjustments right so what's the next important thing that okay, now the weight adjustments are calculated here. I mean, here, this neuron, I mean, this neuron, sorry, this weights, right? So then this is backpropagation code since like, give me a second. It's backpropagation since like we are going to propagate these 5, 6, 7 weights back. Now you can see backpropagation is realized here as well. We are going like get from y1 and y1 y1 y out y1 y1 y6. Now we are coming backwards, right? Not exactly here, but in the next thing you will find like so we calculate the output layer weight adjustments here, right? So in order to calculate the input layer, right? So the layer 1, so the hidden layer 1, right? Hidden layer 1 weight adjustments we can use. Now we have to calculate then. Okay, let's say now we need to calculate weight 1. So weight 1 is what? weight 1 is this one, right? Okay, so let's assume that we need to calculate the weight adjustment of W1. So what we can do, uh, shall I go to the other one? Yes. Okay, so now in order to adjust the weight 1, you need to calculate DABA error total, right, over DABA W1, right? So I can write it again and show you that right? I can show you it again that there are no any W1 terms here in the error total. So you can't apply directly, you can't apply the differentiation here. You can't get the partial derivative here, right? So you have to use the chain rule again, right? You have to use the chain rule and somehow find a connecting function, right? Apply a chain, right? So what you can do here, you can then get it like this, applying chain rule and get uh, this one, right? So you will basically going to do this. DABA error total DABA W1. So this will be equals to DABA error total divided by DABA out. Yeah. Sorry. Yeah. So what we did there, H1, the YH1. Yes. Yeah. So DABA YH1. So H1, you can remember the output of this one, right? H1 and then DABA YH1 divided by DABA Y1, right? And DABA Y1 divided by DABA W1. So you can apply the chain rule again similarly, right? Understood. So this method, doing the same thing, you can calculate W1, right? So try it. I'm not going to do it again since it's going to take time, right? So backpropagation, what do you mean by backpropagation here, right? So the term backpropagation. So can you see that we first calculate the weights of the last layer, right? That means here these weights were calculated, weight adjustments were calculated. That means we use the error. So can you see like error versus the predicted y, right? Predicted y versus the y value, y versus the weight, and so what we are going to do, like we are going to calculate the y, and using that y, we are going to take the error. Using the error, we are going to calculate the weight adjustment of this layer, right? We are going to calculate the weight adjustment of this layer. Using them, we are going to calculate the weight adjustments of this layer. Using these weight adjustments, we can calculate if there is any other layer, we can calculate the weight. So that's why we call this backpropagation. So training of the neural network is forward propagation, right? I mean, sorry, the prediction is forward propagation, right? Prediction. So here we are going to get right. So we got y1 and y2 out using forward propagation. ඉස්සරහට values ආව. It has in the weight adjustments. What we are going to do, we are going to backpropagate, right? Backpropagate. So that's why we are going to call this backpropagation algorithm, right? So in backpropagation algorithm, we are basically going to apply the chain rule in calculus, right? That's what you call the backpropagation. Now you will find, now if we have like several other layers, we have like several other terms here, right? Okay. So simply, this is what you call the backpropagation. So why it's called backpropagation? We are going to take the y output, and using that, we are going to like apply the chain rule and calculate the weight adjustments of this layer. Using these weight adjustments, we are going to calculate the weight adjustments of this layer, right? So that's why we are going to like we are going to use the term backpropagation for this algorithm. right? Understood, right? Right, any issues regarding the backpropagation algorithm? I will post the video that I got this calculation, right? So all the things will be included here. I post that video as well, so you can work it yourself as well, right? I mean, the remaining part, the remaining weight adjustments, right? Okay, now everything is completed. Now we have the gradient descent algorithm and the backpropagation algorithm as well. Now, what I think now, the basic thing is that you are not going to understand it by looking at this, right? So what we have to we have to go through this again, right? And go through the materials that I'm going to provide you, right? So go through the materials that I'm going to provide you, and like you have 1 week to go through this. Now, if you are coming to the next session without looking at these things again, right, that won't help, right? Waste of 12 weeks, right? So you have like do your works and go through the theories uh, that you are going to like cover in the week before coming on to the next week. Yes. Again, so if you have any issues regarding the backpropagation algorithm, okay, right? So please go through this again and try to like recall these things. Yes. Yes. Any issues? Someone? Okay, no, right? Okay, so keep these things. I know that this mathematic part is always hard, right? So you have calculus, differentiation, partial derivation, but you need to keep the idea in your head, right? I mean, keep the idea what's going to happen in backpropagation, what's going to happen in gradient descent, right? So likewise. Okay, yes. So we will quickly move on to the practical implementation, then most interesting part, right? Okay, so I hope that everyone has Keras and TensorFlow installed in your computers, right? Uh, yes. So I will open the Jupyter notebook, right? Now I think everyone know how to open the Jupyter notebook and get a new notebook, right? දැන් මම theories ගැන ප්‍රශ්න අහන්නේ නැහැ කියලා මේ theory part අමතක කරලා දාන්න එපා, right? These are important. You have to keep those things in your mind. So anyone had issues in installing Keras or TensorFlow? No. Okay. So I will go to the desktop and I have my own folder DL on day 3 practical, right? So here I have a data set, the iris flower data set, the CSV file. I will provide you this, the CSV file of iris flower data set. So this is a comma separated value, the CSV value. Now, can you remember what's iris flower example? I think you can, right? So anyone not aware about the iris flower example? Anyone, please? You mean the previous slide? You mean the written note? The written note, right? Okay. Now, meanwhile, anyone, yes, anyone not having idea about what's iris flower example, the iris flower data set? I will upload this handwritten note as well, so you can get it, right? I will upload this handwritten note as well. dy2 dy2 out. Okay, so dy2 out is, so one is asking about d1 dy2 out. So dy2 out is the output of this neuron, right? This one. So probably we have calculated it here. This one. The output of the last layer's neuron, second neuron. This one. Okay. So again, I'm asking anyone. Okay, I will show you that. So that will be easy, right? The iris flower example. Okay, so iris flower example is basically right. So we have yes. So we have a problem like this, not a problem, but yes, anyway, right? Okay, so we have like three flowers called versicolor, virginica, and setosa, right? So the thing is now these are in the same family. These flowers are in the same family. So the thing is that like we are like looking for a method to differentiate these things, right? So I mean identify these three types of flowers: versicolor, virginica, and setosa. So Ronald Fisher, there was a biologist and uh, a mathematician. So he was, I mean, he suggested a method to like identify the sepal and petal and get the sepal length and petal width. So they are different. If you take the measurements of sepals and petals, the width and the length of those, so there is a difference between these versicolor, virginica, and setosa, right? So that's what they have mentioned. So what we are trying to do here, this is a classic example in machine learning, right? So we are going to analyze this problem uh, like this. That means, okay, uh, like, right? Uh, we are going to like take features, right? right? Yes. So, right. So we are going like we are going to analyze these features here. So features will be 4 features will be there: sepal length, sepal width, petal length, and petal width. And labels will be right. Uh, labels will be setosa, right, virginica, and versicolor, right? Features, sepal length, right? So we can, I mean, apply this thing into a what you call a supervised type machine learning problem. We can analyze this as a supervised type machine learning problem. So this is sepal length and this is sepal width. So this is the petal length and this is the petal length and petal width, right? Understood, right? So what we are trying to do here, we are going to analyze this as a supervised type machine learning problem, right? So in supervised machine learning, you can probably remember the supervised type model. Uh, right? So we are going to like analyze this as a supervised type model, right? Okay. Uh, right. So features and labels. So like we are going to get sepal length, sepal width, petal length, petal width, and labels will be 0, 1, 2. 0 for setosa, 1 for virginica, 2 for versicolor, right? So that's what we are going to do in this problem, right? A simple problem, fundamental problem of machine learning and deep learning. Okay, so yes. Okay, so let me get quickly a new notebook, right? So I'm here now where my CSV file is located, right? So I'm going to get a new Python 3 file, right? And my Jupyter notebook will be opened here, right? And let me uh, resize this a bit. Okay. Yes. Yeah. So this is my Jupyter notebook, and so we have a data set. The Excel file is there, right? So Excel file. This is what we are going to find in the Excel file, right? We have like one row. In a single row, we have like uh, several columns: sepal length, sorry, sepal length, sepal width, petal length, and petal width, and the whether it's setosa, virginica, or versicolor, right? Uh, yes. Okay. Uh, yes. So what we can do here, give me a second since like it's better if we can have the other. Yeah, so I have the other method, other file type as well. So let me use that one, so it will be easy for us. Okay, so here yeah, right. So here now we have like 0 for Setosa, right, and 1 for Virginica, and 2 for Versicolor, right. So the targets are in like 0, 1, and 2, right. Okay. So what we have now, we have a Excel file with like which contains the iris flower dataset, right? Iris flower dataset. Now, what do you mean by iris flower dataset? I will show you it again. Now, in this one, what you have is this, right? So, like we have 150 entities, right? 150 entities. So, in that dataset, we have like the column sepal length, petal width, and the last row gives like, okay, so this is a Setosa, this is a Virginica, this is a Versicolor, likewise, right? So the only difference here is that in our data set, instead of Setosa, Virginica, Versicolor, we have like 0, 1, and 2. අපි ගාව තියෙන 0, 1, 2 කියලා. 0 කියලා කියන්නේ Setosa, 1 කියන්නේ Virginica, 2 කියන්නේ Versicolor වගේ. Understood, right? So that's the only difference in our data set, right? So first step is to read the data set and take into our code, right? So reading CSV files, reading Excel files, reading DAT files, reading text files, right? So anything related to machine learning, data science, or deep learning, if you are like reading something from a file, better to use the pandas module. We have a module called pandas, so we will import it. Import pandas as PD, right? So I'm going to import the, we have covered these things, right? I mean the modules. So we are like importing the pandas. Now you may have issue. No, we need to like yeah. So do we need to install pandas? Yes, normally yes, right? If you are using any other development environments, most probably you have to install this separately. But thing is in like Jupyter, as I mentioned, this Jupyter notebook and the Anaconda Navigator is specially designed thing for data science, artificial intelligence, machine learning, deep learning related things. So inbuilt, when you are installing Anaconda, the pandas will be installed. But in other cases, you have to install it manually. So import pandas as PD. In pandas library, we have a function called read CSV. So probably we can use it here. We can directly read the CSV file. Now, in order to do that, what you have to do, I'm going to get the data set using PD. PD now, we are going to call a method in the PD module. We covered this last time. Pandas module, I'm going to call a method read CSV. Right, so we are going to read the CSV file. So you can give the path iris.csv since the Excel file is in the same location where my code is now, right? Code එක තියෙන තැනමයි CSV file එක තියෙන්නේ. ඒක හින්දා මට කෙලින්ම දෙන්න පුළුවන් pd.read CSV කියලා. Now මේක මෙහෙම read කරද්දි මේක එන්නේ data frame එකක් විදිහට. Something called a data, the object called data frame, right? A data frame. Right? So the thing is now, I mean, the data frame is pretty like hard to handle. But what we can do, we can directly using dot values, we can yes, you can read it from elsewhere as well. Now, I mean, we have to do the path here, exact path. My computer C, right? Like my docs, right? Likewise, you can give the path. Right, so we have to do the path here. Yeah, so dot values. So in the dot values, I mean, without dot values, this data set will be something called a data frame, pandas data frame, right? But if you are going to use dot values, it will be directly loaded to something we are familiar with, a numpy array. So if you call like dot values, this data set will be loaded into a numpy array. So which we are quite familiar of, right? NumPy arrays, right? So let me like load the data set. So I'm going to run it, right? So it will take some time at the initial run. Yeah, so now it's loaded. So let me print it and see, right? So you can see now this is a NumPy array, right? A NumPy array, right? A NumPy array. Got it, right? Good. Right. So now I hope that you are familiar with NumPy arrays, right? So now we need to like get the data and targets, so the features and labels, right? So in our right, so if we take like a data set, right? So now this is the data set. Now we know few things here, right? That these things are right. So these things are the features, and these are the labels, right? That's something we know. Now in standards, we call these values, right? These values, now the feature values, as data. Now today onwards, we are going to refer them as data, right? Data. And these set of values, sorry, these set of values, we are going to like refer them as targets. Right? Data and target. Now, you know, these are features and labels. So features are sepal length, sepal width, petal length, and petal width. Labels are setosa, virginica, versicolor. But these values are referred as data, and these values are referred as target. Right? Data and target. Understood? Okay. So what we are going to do now, we will split the data and target. Okay. So can someone suggest me a method to get data from the data set and target from the data set? See, all rows, first 4 columns. All rows, 4th column. Is it right, or I have done some mistake? මේක හරිද? දැන් මතක් වෙන last week මම මේ ඕන තරම් කියලා දුන්නා. දැන් මේකයි numpy arrays ගැන අපි කතා කරේ. මේ බලන්න බොහොම ඔච්චර ලේසි data and targets ටික වෙන් කරලා ගන්න. Yes, is this okay? Yes, this is correct, right? This is correct. So what it refers, I mean, the first row, I mean, so this is iris flower data set, right? This is what you call the iris flower data set. Right? I mean, මේක නෑ මේ column එක සාමාන්‍ය data set එකේ නෑ Excel file එකේ නෑ. මෙන්න මේක 0 1 2 3 4. ඉතින් 0 1 2 3 4. 0 to 4, that means these columns, and 4th column, right? So 4th column will be taken into the targets. Understood? Right? Got it? Right? Yes. So please ask, right? So if you have, I mean, last week අපි මේවා කතා කරා, දැන් මේක තේරුම් නැත්නම් අහන්න ඕනේ, right? මම පොඩි example එකක් කරලා පෙන්නන්න මේ බලන්න දැන් අපි data set එක print කරලා පෙන්නුවොත් එහෙම right අපි මෙහෙම කරන්නේ 0 මේක තමයි 0 column එක first column second sorry 0 1 2 3 4 අපි 0 ඉඳන් 3 වෙන 4 වෙනකන් ගන්නවා මේ ඒ ටිකයි all rows ඊළඟ මේකට ගන්නේ fourth column එක understood so right okay so you can check it right so this is data let me run this first data right and this is target right okay so that's it right so now we have loaded the data now we are going to like implement a neural network to for this data set to train a neural network for this data set right okay so we will use Keras from Keras dot layers import dense dense is it D capital yes I think import dense so dense is like now in Keras we have several type of layers now what is Keras actually yes Keras Keras is the front end we are using as I mentioned in the previous weeks we are using actually TensorFlow we are dealing with TensorFlow right අපි TensorFlow තමයි use කරන්නේ right we are using TensorFlow ultimately but the thing is that we are not directly coding into you can directly code in TensorFlow it's fine but it's a bit hard so we have a front end called Keras front end කියලා මේ ලස්සන මේ graphical user interfaces එක කියන front end එකක් නෙමෙයි again a Python code right so we are using this Keras front end which makes neural network implementation bit I mean quite easy right so it makes quite easy I will show you you can similarly code in TensorFlow as well but it's a bit hard so we are using Keras it's easy what Keras is going to do Keras is going to convert the code that we are going to write into a TensorFlow code in the backend so that means like ultimately we are implementing a TensorFlow code but we are implementing in Keras Keras is going to convert it for us right Keras.layers import dense so dense layers now this is a layer type in Keras dense layers are the feed forward neural networks that fully connected layers dense layers කියලා කියන්නේ fully connected layers වලට අපි දැන් මේ ගන්නෙ Keras වලින් fully connected layers implement කරන්න ඕනේ අපි කියමු construct එකක් කියලා right we are going to take a constructor to implement a fully connected layer right okay and also we need to like get some other thing from Keras dot that models sequential right so in Keras we have two main types of two main methods of implementing neural networks in Keras two main methods of implementing neural networks in Keras the first one is the sequential method other one don't have that a special name but for the first I mean in autoencoders in generative adversarial networks in reinforcement learning deep QNets we are using like the other method but here for the like recurrent neural network convolutional neural network feed forward neural networks we use the sequential method right so we will get to the remaining method the second method of implementing neural networks later but the sequential method is the most simplest and the fundamental neural network implementing method where we can implement we can define a neural network model like this right so now model is a sequential type neural network now sequential type is not a theoretical neural network like feed forward convolution or recurrent no not like that sequentially it's a type they have given us to implement neural networks in Keras so Keras is a sequential type so now what's going to happen this is going to create a empty neural network right a empty neural network empty neural network so what I mean sequential as the name suggests what we can do we can add layer by layer to the neural network so this is empty neural network then we can add layer by layer to the neural network so model.add so this is the first layer that we are going to add. So model is an empty neural network. We are going to add layer by layer. The first layer will be added here, right? Okay. So I mean, what's the first layer to be added? ඉස්සල්ලාම දාන ඕනේ layer එක මොකක්ද neural network එකට? Yes. Yes, the input layer, right? The input layer should be added. Now, yes, but the thing is now, most of the time, sometimes we are going to add. Now, can you remember that the input layer is, I mean, we are not going to do anything with the input layer. Can you remember? I mean, that's some kind of, right? A placeholder actually, right? So can you remember now? This is going to like hold the features for us, right? Hold the features for us, and those will be passed to these things. Now, I mean, the input layer, the neurons in the input layer, right, don't have any activation function, right? Don't have biases, right? So usually, most of the cases, we can define the neural network without mentioning without adding the input layer. සාමාන්‍ය input layer add කරන්න නැතුව අපිට ගොඩක් තැන්වලදී සමහර තැන්වලදී input layer දාන්න වෙන තැන් වෙනවා. හැබැයි ගොඩක් තැන්වලදී අපි input layer දාන්නේ නැහැ. අපි දාන්නේ first hidden layer, right? අපි හිතමු අපි මේ problem එකට මෙන්න මේ වගේ neural network එකක් design කරනවා කියලා. 8 16. How many neurons should be there in the output layer? Huh? How many neurons should be there in the output layer? 3, right? Since we have 3 labels, good, right? For Setosa, Virginica, and versicolor. And these are for sepal length, sepal width, petal length, and petal width. Okay, so first we are going to, I mean, මම කියන්නේ හැමතැනම නෙමෙයි සමහර තැන්වලදී අපිට input layer එක නැතුව define කරන්න පුළුවන්. It's like this. Model.add dense. So we are going to add the dense layer first. Model.add dense. So then we have to mention how many neurons. So I'm going to add the first hidden layer, 8 neurons, right? Then we have to mention like the activation function. ගොඩාක් parameters තියෙනවා මේ neural network layer එකක් හදද්දී දාන්න. So we are creating a layer, right? We have like several other parameters to be given, but we are like only now for today we are only using the like the most required things, right? Only the mandatory things, right? We have like several other, I mean, we have like 25 parameters. If we take like the single layer, we can pass 25-30 parameters to create a neural net a layer in a neural network. But for today, for the simple implementation, I'm only passing whatever the required things, right? So then we have like use the we have to mention what's the activation function of this layer. Sorry, one other thing. Input dimensions, right? That means we have like mention how many neurons are there in the previous layer, or how many inputs are coming, from how many neurons inputs are coming for the hidden layer that we are going to create here. So how many neurons are there in the previous layer? Should be there in the previous layer, yes? Yes. And then we have to mention the activation. So what you are going to use as the activation? Can someone suggest me an activation function to be used here? Yes, you can use anything. I mean, ReLU, TAN, sigmoid, anything, right? Nonlinear activation function, any nonlinear activation can be used here, right? So this is the first layer. We added the first hidden layer. We have added the first hidden layer here, right? So similarly, we can add the second hidden layer. So it's 16, and the input dimensions will be 8, and the same activation. Let's use the same activation, ReLU. The second hidden layer, and yeah, so the third layer, 8. Okay, then do we need to add the final layer, the output layer? Do we need to add the output layer? So my question, do we need to add the final layer? Actually, silly equation, right? No, yeah, we have to add it, definitely. Otherwise, the neural network won't be completed, right? So, so what is the activation function? Are we going to use the same activation? And this should be 3, right? Yes. So, are we going to use the same activation, or are we going to change the activation? Yes, quickly. Yes, quickly. Now, are we going to use the ReLU activation for the output layer? Okay, so first tell me, is this a classification for a problem or a regression problem? Classification, okay. So then I repeatedly mention what is the activation function that we are using, what are the activation functions that we can use for the last layer of a classification problem. Yes, sigmoid or softmax. So better to use a softmax, right? So you have to go through the lecture slides again, I mean the videos as again, right? Otherwise you are not going to remember these things, right? Okay, so finish. Now, do we need to mention that we have finished creating the neural network? No, not like that. So I mean, when you are going to finish adding the layer, that is the that will be the end of the neural network. So we have like a nice little neural network which takes yes, yeah, take 4 parameters as the input and output 3 parameters, right? A classification type problem. So then we need to compile the neural network. That means we had use some parameters, model.add. We have to give the loss calculation, the method of loss. What's the loss calculation method? What's the loss function that we are going to use for this quickly? So that's why I'm always saying these are quite related to the theory that we discussed. Yes, the loss function. What's the loss function we are going to use for this kind of a problem? Quickly. Yes. Yes. What's the loss function? So how many loss functions we have? Like 2 main types of loss functions are there: regression and classification. For regression, we are going to use mean squared error. For classification problems, what we are going to use? Uh, yes, not binary for this one. Yes, you can use binary, but this is category. We can use the cross entropy loss, but here we are going to use the categorical cross entropy loss. Categorical cross entropy, right? Cross entropy, categorical cross entropy. Categorical cross entropy is used when you have like, now we have multi-class, multi-categories, right? So categorical cross entropy. Now you can remember the cross entropy loss will be used for classification problems. Then we have to use what, when we have to say the what is the optimizer you are going to use. Optimizer, the optimizer that we are going to use. So what's the optimizer that we need to use? Yes, anyone? Optimizer. Yes, the gradient descent. First, we will use the gradient descent algorithm. Then we will move on to like the Adam or the Ada delta or whatever things. First, we will use the gradient descent algorithm, right? Yes, so we will use the stochastic gradient descent algorithm, SGD, right? Then, like there's another thing to be mentioned. Now, metrics equal, we are going to use some metrics here, accuracy. Now, this is not related to the neural network, but what happens when you are going to train the neural network, the accuracy of the model will be shown, right? The accuracy of the model will be shown. That's it. Now, this is not related anything to the neural network, but when the neural network is trained, you can see the accuracy of the neural network, right? Okay, so we can then get the model.summary to make sure that everything is there as we expected, right? Let me run this one. So can you say, it says now we are using Keras, but it says that originally the Keras is using TensorFlow backend. So at the initial run, it takes some time, a few seconds. So this should be model.compile, not that. So the model.summary, right? So this method gives us this. Now it says how many parameters are there in the each layer, how many parameters, how many trainable parameters, how many non-trainable parameters are there. Right? Yes, so now here it says, okay, so we have the first layer, 8 neurons are there, 40 parameters are there, 40 trainable parameters. What are the 40 trainable parameters? So you can see here 8 into 4, 32, 32, right? Plus 8 biases of this first hidden layer, 8 biases of this first hidden layer, right? And we have like in the second layer, 144 parameters are there. So what is 8 into 16? 8 into 16. So it's like 128, right? 128. 128 plus 16 biases. 128 weights plus 16 biases. And similarly, 128 plus 8 biases, right? And the last layer we have like 27. 18 to 3, 24 weights plus 3 biases, 27, right? 27, 27 trainable parameters. So here like total trainable parameters, we have like 347 parameters. That means the y or the output is like a function of x with the 347 parameters. That means the error is dependent on 347 parameters. That means the gradient descent algorithm should, for each training, it should just 347 parameters. It means like the backpropagation algorithm should find the apply chain rule and find the 347 gradients, right? So that's what you mean. And what do you mean by non-trainable parameters? Are there any non-trainable parameters in neural networks? Yes. I mean, I will I will show these things later, I mean coming weeks, that sometimes we can freeze the way some weights and biases of the neural network. So these are commonly used in neural networks for some special cases, that some layers we can freeze those layers. That means the weights and biases of those layers will not be adjusted, right? The weights and biases of these layers will not be adjusted. So likewise we can freeze. සමහර neural network සමහර තැන්වලදී සමහර special task වලදී අපිට පුළුවන් neural network එක freeze කරන්න. සමහර layers freeze කරන්න. So what's going to happen? Like it's not going to adjust those weights in the freeze layers. Freeze කරපු layers වල weight adjust වෙන්නේ නැහැ. So those kind of things are called non-trainable parameters, right? So we can have non-trainable parameters as well. We will talk about these things eventually in our course, right? Not today. Everything will not discuss today. Okay, so we have a neural network ready to train for our problem, right? Okay, so then we have a data set. Now what we are going to do, like we have to do several things here now, right? Give me a second. Right, okay, so let's say if you have a data set like this, right? So we know that this is called the data, right? So this is data, and we know that this is the target. Anyway, right? So this is data, and this is target, right? So when you are going like, sorry. So this is data, and this is target. Now, usually when we have a data set, right? When we have a data set, this data set usually will be split into three main categories, right? So three main sets, right? Training set, validation set, and the last type will be testing, right? Training, validation, and testing. Usually when we have a data set, we are going to split it to three main sets called train set, validation test, and training data set, validation data set, testing data set, right? So the same data set will be split into three, right? I'm not going to talk about the validation today, right? So it will be done on next week. So this will be like, we are not going to cover the validation data today, but training and testing data, I will explain what you mean by training and testing. So what we are going to do, like, if you get the data set, if you are going to get the data set, we are going to like convert it. I mean, we are going to split it to two main today, right? But usually we have split it to three. But today I'm going to only talk about training and testing. So what we are going to do, we are going to like divide the data set into training and testing. So this means that the data will be split into something called train data, and the data will be again split into something called test data, and also the target will be the same target. Sorry, uh, the target will be split into uh, train target and test target, right? So it will be converted into train target and test target, right? Understood. So how it's going to be like carried out like this. Uh, Now we know this is data, right? So we are going to mention a param. I mean, we can do it like using the code. Uh, we are going to mention a parameter called test size, right? Test size. So usually let's say test size is 0.1. Uh, yeah, so let's say the test size is 0.1. So what's going to happen? Like this means 0. Yeah. So this means like for training, we have 90% from the data. For testing, we have 10% from the data, right? 90% for training, 10% for testing. So what we are going to do basically for train data, right? For train data, we are going to like randomly select, right? So let me color this in a separate color, train data. Okay, and also train target, right? So we are going to select 90%. Yes, we have a question. Let's see. Uh, is it okay? Right. So it's like this. Now, right? Yeah. So let me use the train data and train target in this color. Now, what will happen? 90%. I mean, okay. So let's say we have 100. So 90 will be selected randomly like this. Right? Uh, yeah. Anyway, right. So we are going to like select, right? So 90, right? So it can be this, right? And this, right? So we are going to select 90% to the training, right? Randomly, they will be selected randomly, right? Somehow it will be 90%, right? 90% of the total data set, the whole data set, right? Likewise, like this. And the, right, so what's going to happen, right? So we are going to like select 90, and those will be like respectively go to the train target and train data. Then what we are going to do, we are going to take like, right, for the test, right? For the test uh, data and test target, we are going to again select 10% from the data, right? 10% from the total. Now, if you have like 100 date, 100 columns, 10%, 10 columns will be selected, right? So this is called the train test split, right? Train test split, right? So we can mention the test size here, right? Okay, right? Yes. So we are going to do it now. So now we are going to train the neural network using the train data and test data. We are going to then test the neural network using the test data and test target. Now, what's the importance of testing the neural network? I neural network එක test කරන්න ඕනේ වෙන්නේ. Right? ඉතින් ඒක මේ වගේ ප්‍රශ්නයක්. ඇයිවා exam එකට ගිය නැමෙ. ඔයා මේ exam එකට යන්න කලින් ඇයිවා මේ ඉස්කෝලේ තියෙන term test වලට ලියන්න ඕනේ. ඔයා pass papers විතරක් ලියලා හිටියා නම් ඇතිනේ. learn කියන්නේ pass papers විතරක් ලියලා හිටියේ ඇයි ඉස්කෝලේ test වලට ලියන්නේ? You have to like evaluate yourself, right? So you have to evaluate yourself. You are going to learn from the past papers, right? But you have to like sit for the term test in the school to evaluate yourself. You don't know. You don't know your training is achieving the results you are looking for, right? තේරෙනවද ඒ වගේ දෙයක්. එතකොට neural network එක අපි actual දෙයකට දාන්න කලින් මොකද අපි කරන්නේ? Right? From the data set, we are going to like use 90% and we are going to train it. And then these can be changed like 80% to 20%, likewise, they can be changed. But somehow we have like test it. Right? So like let's say self-driving car, we are going to train it using 90% of the images and the steering angles obtained. And before running it in a real road, we have to check the neural network. We have to check the neural network by applying the remaining 10%. ඉතුරු 10 දාලා අපි බලනවා කොහොමද neural network අපේ results දෙන්නේ කියලා. So before like using a neural network in a practical application or in the real world, like what we are going to do, we are going to first collect a data set. First, we are going to using like a majority percentage, like let's say 90%, we are going to train it, and using the remaining 10%, we are going to test it before using it in real application or real world implementation. ඇත්ත self driving කාගේ ඇත්තකට දාලා ඇත්ත පාරකට දාන්න කලින් අපේ ඉතුරු images දාලා බලනවා මෙයා හරි results දෙනවද කියලා. ඔයා හරියට exam එකට යන්න කලින් ගිහිල්ලා උත්තර ලියන්න කලින් ඉස්කෝලේ term test එක ලියලා බලනවා මොනවද මේ results කියලා. Right? Similar thing, right? Okay. So we can do it in the code like this. Right? So we can use a function in scikit-learn library, right? Scikit-learn, you know what scikit-learn? Scikit-learn is the library provided by Google for machine learning algorithm implementation. Machine learning algorithm implement කරන්න Google අදින library එකක් තමයි scikit-learn කියන්නේ. මේ scikit-learn කියන library එකේ තියෙන හොඳ function එකක් අපිට use කරන්න පුළුවන් මෙන්න මේ data set එක training and testing වලට බෙදා ගන්න. So we can use the scikit-learn library, which is provided by Google, and we have like a very versatile function in a method in scikit-learn library, where we can use it for like splitting the data set into training and testing, right? So from sklearn, from scikit-learn library, I'm going to import sklearn.model selection. We have a subcategory, sublibrary called model selection. From that, I'm going to import the method train test split. Train test split, right? So this is a method, a function, let's say, right? මේ function එකෙන් තමයි අපි අර train test split කරගන්න use කරන function එක. අපිට මෙතනින් හරිය හැම code එකකම අපිට මේක use කරනවා this function, right? Okay. So this train test split function, we have to pass several parameters, data, target, right? Data and target, you can remember, right? The features and label values we took. And then we have to mention that the parameter I mentioned, test size. So 10% for training and 10% for, 90% for training and 10% for testing, right? So it's going to split the data set into that. And this is going to, this function is going to return us 4 things, right? This function is going to return us 4 things. So the first, the train data and test data and train target and test target, right? So it's like this, that if you can like exactly get the idea directly, data will be splitted into train data and test data, right? So the target will be splitted into train target and test targets, like 90% for this, right? So 90% for tray, 10% for testing. Here also 90% for training, 10% for testing, right? Now the important point here that don't think it like this, right? Okay, දැන් මෙතන මේ මම පෙන්නපු මෙතන මේ මම පෙන්නපු විදියට යන්නේ දැන්. So if the second row is, I mean the first row is selected to training, right? ඒක training වලට ගියාම එතනටම තමයි මේ data එක යන තැනට තමයි target එක යන්නේ, right? Understood? So if this is selected for training, this will be also selected for training. The same thing, right? I mean මේක යනකොට පළවෙනියට මේක train data වල පළවෙනියට මේ පළවෙනි row එක යනකොට, right? පළවෙනි row එක train target වල පළවෙනියට යනකොට, sorry, train data වල පළවෙනියට මේ row එක ගියොත් එහෙම train target වල පළවෙනියට යන්නේ මේ row එක, right? Test data වල පළවෙනියට මේක ගියොත් එහෙම test target වල පළවෙනියට යන්නේ මේක. Understood, right? So keep that thing in mind, right? Okay, so you can use this function directly. So this train test split function is going to give us directly 4 returns: train data, train target, test target, as I mentioned last time. Right, understood. Okay, so run it. Before this, I want to like do something else as well. Now, can you remember the target? Right, so it's like this. So my question, can we apply this target directly into the neural network? No, what's the reason? Yes, no, what's the reason? Text, no. The neural network is not trained. No, or we are going to train the neural network. Now my question, why we can't apply this target directly? I mean, for the training, we can't apply directly for training. We can't apply this for training. Yes. Data with target. Oh yeah, we can. We have to apply the both. I mean, the data and target, train data and train target should be applied. But my point is not that. What I wanted to highlight is that now this neural network has 3 neurons in the output layer, right? 3 neurons in the output layer, right? So this is for setosa, let's say, and this is for virginica, let's say, and this is for versicolor, right? So now this 0 means what? 0 means this 0 means what? 0 means setosa, right? But setosa is not 0. It's what? It should be what? It should be 1 0 0, right? Then only the neural network can get the error between the predicted output. Can you remember? Right? So the setosa should be like 100, right? And the versicolor should be like what? Huh? The versicolor is 010. Can you remember? And the sorry, Virginica. The versicolor should be something like what? 001. So this is called the categorical form, right? So we need to convert it to the categorical form. Otherwise, otherwise, how to get the error, right? So can you remember the error? Y1 actual minus Y1 predicted, right? The square root plus Y2 actual minus Y2 predicted, the square root plus Y3 actual minus Y3 predicted, the square root divided by 3. Can you remember? So in order to get this, we need to have this kind of relationship. Then we can say, okay, 1 minus whatever the value, right? Also, so we need to convert this into the categorical representation. So that could be done. Is it one hot encoded? Yes. Yeah. So this is called the hot encoded as well. One hot encoded. So this is referred as one hot encoded as well. Okay. So we can do it. We have another method in Keras. From keras.utils import numpy utils, np utils, and using that we can get, I will convert it to new target, something called new target. New target equals, we have functions to convert this directly to categorical form, np utils to categorical. So we can give the target, right? So what will happen? The target will be converted into the categorical form, and it will be coming here. So let me print the target, new target as well, so then you can compare it. So can you see now? 0 is represented by 100. Here 0 is represented by 100. So likewise, after 50 elements, so this one is represented by 010. At the last 50, it's like 001. Understood? Right? So this is called the categorical conversion, right? So now we are good to go, right? We are good to go now. Now we can train the neural network. It can be trained using the fit command, model.fit, model.fit. And right, so we have to give the train data, right, and the train target, right? So can you remember now? What we are doing here is this. Right, so this thing, giving train data, train target, train data, train target. Using train data and train target, we are going to train the neural network. So that's what we are doing here, right? So everything matches with our theory, right? And then what we have to give, like, yeah, train data, train target, and we can mention the number of epochs. Epochs, how you can remember what's the epochs, right? Let me give 100 epochs here, right? And the information of the neural network training, yeah, no, you can train it like this, right? Okay. So that's it. Later I'm going to add more parameters, but for now this will be the output, right? So this, we can add some parameters, we can provide some other parameters, but for this instance I'm only going to use these simple parameters: the train data, the data target, and the number of epochs. And the other thing I forgot to, like, I got it to, like, the new target, right? So we had to, like, give it here as well, new target. Then do the split again, right? Do the split again, and run it. So now you can see the neural network started training. All right. Yes, so ultimately it reaches like this accuracy, right? Now I want to highlight few points here. Okay, so can you see now the initial, now the military couldn't train right? So it took like few seconds actually. Now this is nothing like only like we have like 347 parameters to be adjusted and like four features and three labels. So this is not going to that much time, right? So this is taking like no time to train, right? But you will see when we are dealing with convolutional neural networks and when we are coming to like deal with images and time series data, it will like take days. It will take hours to train a neural network, right? But today, not it's a simple neural network. What I want to highlight is now, can you see the loss is decreasing here, right? So this is the epoch 1 and the accuracy remains at 34%. The loss is decreasing, but the accuracy is not increasing. What's the reason for this? Yes. දැන් epochs මුල් epochs ටිකේදී මේ පළවෙනි epochs 10 11 යනකම්ම accuracy නේ කීයද? ගොඩක් නේ. epochs 20ක් 30ක් විතර යනකම් accuracy එක වෙනස් වෙලා නැහැ. loss එක අඩු වෙලා තියෙනවා. right? මොකද්ද මේ accuracy කියලා කියන්නේ? Right, so it's like this. Right. Okay, right. So our problem, I'm going to only consider the output layer, right? I'm going to consider the output. Sorry, this. Yeah, I'm going to only consider the output layer. So 3 neurons are there. Okay, right? The output layer. So this is the output layer, right? So how many data? So how many data elements we have? Like 150. Right. Okay. So let's say, okay, the first one. So the first data, right? Right. So, right. The first data is applied and y predicted and y actual, right? Y predicted and y actual. Following data point එක add කළා predicted එක actual එක. අපි හිතමු predicted එක මේක කියලා. Right? ඔය පළවෙනි data එක add කළාම මෙහෙම එනවා. Right? So we can get the loss, right, using the categorical cross entropy, right? Using the categorical cross entropy, right? So what's the accuracy here? How we are going to measure the accuracy? You can get the loss. Loss එක ගන්න දන්නවනේ. මම කියන්නේ accuracy එක කොහොමද ගන්න? Right? Accuracy will be number of correct predictions divided by number of total predictions. Okay. Then මම මේ කරන්නේ, let's say this is the first epoch, right? අපි ගා 150ක් data තියෙනවා, right? 150ක් data තියෙනවා. right? අපි කියමු මේ පළවෙනි epoch එක කියලා. පළවෙනි epoch එකේ පළවෙනි data point එක දැම්මහම මෙන්න මේ වගේ result එකක් තමයි neural network එකේ. So this is the first epoch and we are going to apply the first data. පළවෙනි row එක දාලා බලන neural network එකට මේක තමයි එන result එක. So what will be the accuracy here? Accuracy? Yes. How many correct predictions? මේ දුන්න ප්‍රෙඩික්ෂන් එක හරිද? නෑ මට කියන්න. හරි. correct predictions total predictions කීයක් දියත් කියන්නද මෙතන? How many total predictions? Yes, quickly. We are running out of time. Yes. How many total predictions given? I mean, at the moment. Yes. How many total predictions given here? No, not three. I mean, three is basically like the probabilities, not the outputs. Ek a prediction, one prediction, right? So this is a single prediction here. I mean, now I'm talking about the මම කතා කරන්නේ මේ දැන් මේ එකයි මොකද්ද මම මේ කරන්නේ පළවෙනි එපෝක් එකේ තාම අපි ඉන්නේ පළවෙනි සෙටෝස් එක අරන් මේකට දාලා බැලුවා මම නියුරල් නෙට්වර්ක් එකට දැම්මම මේක තමයි රිසල්ට් එක එන්න ඕන රිසල්ට් එක තමයි y. So this I'm in the first epoch and I'm applying the first row of the data set, right? පළවෙනි data set එක මම දාලා බලනවා දාලා බැලුවාම මොකද වෙන්නේ මේක තමයි result එක. Now, how many predictions given by the neural network? How many predictions given by the neural network? Yes. How many predictions given by the neural network up to now? One. Yes, one prediction, right? Okay. Out of them, how many correct predictions are there? How many correct predictions are there? Zero. Yes, exactly. Okay. Right. So then the second will be applied. Right. බලමු second එක අපි කියමු yp ya second row එක දානවා. පළවෙනි epoch එකේ second එක මම දානවා. Right. Okay. Then, how many total predictions? Huh? How many total predictions? 2. How many correct predictions? Yes, 0. So accuracy is 0. Accuracy is 0. Okay. So then, third epoch. So not the third epoch, third row. Yp, ya. Sorry, this should be 0. It's my mistake. Okay, now how many total predictions? How many total predictions? 3. How many correct predictions? How many correct predictions? How many correct predictions? Okay, interesting. How many correct predictions? Yes, I need more answers. How many correct predictions here? How many correct predictions? Others? I mean, you are not going to lose anything, right? So just give an answer. Yeah, good. මම මේ කියපු points මයි මේ අහුවෙන්නේ. මම මේවා කියලා තියෙනවා. හරි. 1 ඇයි? 0.5 වලට වඩා ගියොත් අපි කියනවා එක හරි prediction එකක් කියලා. 0.5 or ඊට වැඩියෙන් ගියොත්. Right? So greater than 0.5 is considered as a correct prediction. If the actual is 1. If the actual is 1 and the predicted is greater than 0.1, that will be considered as a correct prediction. Right? So now what says? Now here it's the accuracy will be like 0.33. Right? So accuracy calculate කරන්නේ. So I mean, so what's the accuracy you are going to get here? right? මේ පළවෙනි epoch එකේ right data 135ම 135 අපි 90ක් නෑ 150යි. So we are like 90% from 150. That's training. So like we are going to apply the whole data set once, and it says like only 34% is correct. Only 34% is correct, right? 135න් 134ක් තමයි හරිය. That's what you call the accuracy, right? Now the next point, right? Now the next point, right? Okay, I will do a similar thing, right? Let me like 150 මම මෙතන ලියන්න යන්නේ නේ. Okay, right? So let me so I'm taking a lot of time here, right? පොඩි දේවල් මම explain කරන ලොකු time එකක් ගන්න. සමහර දන්න කට්ටියන්ට ඉන්නවා මේ කට්ටියන්ට පොඩ්ඩක් boring එක. But කරන්න දෙයක් නැහැ. Like I'm taking a lot of time here to explain these basics. I mean, we can go in like a faster phase, right? Faster phase from next week onwards. But these the initial weeks, I'm going to go from very slow phase and explain these things very clearly, right? So that's how we are going to make the foundation, right? Okay, so then let's assume that I'm going to move to the right second epoch. Our data set එකම ආයෙ පාරක් දානවා. We are going to apply the same data set again, right? The second epoch, right? Okay, let's take like this. I will write it another color. 0.3, 0.6, sorry, yeah, 0.5, no, 0.4, 0.55, 0.05. දැන් මේම actual එක එකමනේ මොකද එකම data set එක නාය දාන්නේ. ඒකට actual එක එකමයි, right? Okay, now okay, tell me the accuracy. Number of total predictions, how much? 1. How many correct predictions? How many correct predictions? Yes, 0. Good. Okay, so then okay, 0.4, 0.45, 0. Okay, how many correct predictions? How many correct predictions? I think the answer is 0, is it? Yes, 0. Okay. And here, the last one. Okay, how many correct predictions here? How many correct predictions? One. Okay, now the question. Okay, now tell me, so is the accuracy same in both epoch 1 and epoch 2? The accuracy same, is it same in the epoch 1 and epoch 2? The accuracy, I'm talking about the accuracy, yes. Yes, exactly. It's no, it's yes, 0.33, 0.33. Accuracy is the same. Yes, it is, right? Is the loss the same in the both occasions, epoch 1 and epoch 2? Epoch 1 එකේ epoch 2 එකේ loss එක එකමද? No, good. Which has the minimum loss compared to these epoch 1 and epoch 2? 2, right? The second epoch has the minimum loss. එයාගේ loss එක අඩු වෙලා. ඇයි මම මෙහෙම කියන්නේ මේ බලන්න. මෙයා එකට ලං වෙන්න ඕනේ. ඉතින් මේ එකට ලං වෙලා. මෙයා බිඳුවට ලං වෙනවා. ඉතින් මේ දෙන්නත් බිඳුවට ලං වෙලා. Can you see? Right? මේ තුන් දෙනා මෙයා එකට ලං වෙන්න ගනවා. මෙයා බිඳුවට ලං වෙනවා. Right? So it's like getting closer to 1. This is coming back to 0. I mean, coming to 0. All the things are like they have improved compared to loss. When we are comparing the aspect of loss, it's improved. Loss එක පැත්තෙන් ගත්තොත් improved, but accuracy is the same. Right? That's why I mentioned at the initial section of the lessons, right? When we are training the neural network, we are focusing on minimizing the loss, not on the accuracy, right? Minimizing the loss is like, yeah, increasing the accuracy, but it's not like visible for some extent. After some extent, the accuracy is rising up, right? But the initially, the loss is decreasing slowly, but you can't see a improvement in the accuracy. තේරෙනවද? ඒ accuracy වැඩි වෙන්නේ නැත්තේ කියලා. මේ වගේ. ඒ බලන්න. කොහොම ලස්සනට මේ වගේ එකක් තමයි වෙන්නේ මේ. Accuracy remains, but loss gradual. Sorry. Right. So you can see, right? So the loss is gradually decreasing, right? The loss is gradually decreasing. The accuracy remains the same, but after some extent you can see it's rising up. අන්න එතකොට තමයි මෙන්න මේවා නේද? එතකොට මොකක්ද වෙලා තියෙන්නේ? Right? මොකක්ද වෙලා තියෙන්නේ? මෙන්න මේවා එතකොට, right? So these kind of points, right? So these are like started like එතකොට දැන් accuracy වැඩි වෙන්න ගන්නේ ඇයි? මෙන්න මේක, right? මෙන්න මේක 0.6 වුණාට පස්සේ මෙන්න මේක 0.5 වුණාට පස්සේ sorry. මෙන්න මේක 0.5 වුණාට පස්සේ ඔන්න accuracy වැඩි වෙන්න ගන්නවා. Right? But loss is decreasing, accuracy is not, but after some extent the accuracy will be also increased. Right, good. Interesting, right? So that's why I told you like we are spending lots of time here, right? These fundamentals. Okay. Yes, so that's what you, right? And can you see now? We can't exactly see it. I will plot the loss and the accuracy separately to show you what happened. So we are using the matplotlib library. Import pld.show model.history number, epoch number, y label will be the loss Okay, I think I don't know why it's not working, but anyway, we had like if we, let's see. I'm not sure. Anyway, so in order to get this thing, you had like make it equal to history here. Uh, as I can remember, let's see. I'm retraining it. Why it's not giving the. Oh, sorry. No, the earlier. Yes, the earlier thing works perfectly. I have done a mistake. This should be plot. Here your plot. This should be here your plot. And you have to like it model the history. History. Yes. Okay. Okay. Now this is a loss. Now what you can see now, like have we run this for like enough epochs, enough number of epochs? මම කියන්නේ අතිතරම් මේකට අපි epochs ගන්න run කරලා තියෙන නැත්නම් තව epochs දාන්න ඕනේද මේක දිහා බලලා කියන්න බලන්න මේ තියෙන loss එක. Do we need to like add more epochs than 100? No need. Add. I mean, do we need to train it more than 100 epochs? Do we need to train it more than 100 epochs? Question. Yes. Okay, I will ask it from another form. Like, so has this neural network reached the convergence point, or has this neural network converged the weights and biases? The loss is optimized. Is the loss is optimized here? No. Then why? Yes, right. So can you remember now? We are expecting, can you remember? I explained these things. We are expecting something like this. Loss and epochs, right? So this is where you are going to say like, okay, converged. Why? With the epochs, the loss is not anymore decreasing. Now here, what it says like, it can go some, maybe understood. So it can like continue and I mean, like, can you see the slope? It's not like this, right? It's like having a slope. That means it can go, right? So we need like find this kind of a point, right? So shall we like add more epochs here? Let me 1000. Now don't run it again here. What will happen? Now it will keep the previous 100 in mind and again train 1000, right? So if you want like from beginning, if you want to train it again, so you have to create the model again and run all the things again and again. So we have like put now 100 epochs here. Yes, now I run the neural network model again, right? So in that case, the neural network will be replaced. Neural network will be replaced. So it's like it start from 0 and run 1000 epochs, right? If you're not going to if you are not going to run it again here, right? If you are not going to run it again, that will be like it will start from 100 and add more 1000 networks, right? So now is this optimized? Now this is the accuracy. In the accuracy, like we can't like see that much information here. See, accuracy is increased. Accuracy is important, but we need to look at the what you call the loss. So is this optimized? Is this optimized? So the critical problem, right? Do or die question. No. Others? Yes, no. Yes, this is optimized, but this is having something that we discussed last time. Can you remember this? Now, this is not the loss and loss versus epochs. This is like the error versus a weight, right? So it's like this, right? It's like it can't reach the minimum, right? It's like going from here to here to here and coming from here to here. Likewise, can you see now the fluctuation, the loss is increasing, decreasing, right? So it can't like, I mean, it has achieved some minimum, but it can't like reach here, right? So can someone suggest me a method to like, I mean, from your knowledge up to now, can you suggest me a method to improve this one and reach the minimum loss? Yes, anyone? මේක මේ දෙපැත්තට පැනනවා වැඩි වෙනවා අඩු වෙනවා මෙන්න මෙතනට යන්න බැරි වගේ දෙයක් මෙයාට වෙලා තියෙනවා මට නම් තේරෙන විදිහට. ඒකයි මේ මෙයා ඔප්ටිමයිස් වෙලා තියෙන යම් තාක් ලෙවල් එකකට මේ වගේ ලෙවල් එකකට ඇවිල්ලා තියෙන හැබැයි මෙතනට ගිහිල්ලා නැහැ. ඒකයි මේ උඩට පල්ලෙහාට යන්නේ. Yes, can anyone suggest? Change the SGD, use backpropagation. Yeah, we are using backpropagation. I mean, when the gradient descent algorithm is working, the backpropagation algorithm was working behind. Change the SGD, yes, good one, right? Asked to change the SGD, yes, I mentioned SGD is not the best, so it's like not, it's not just the learning rate according, right? So learning rate ප්‍රශ්නයක් කියලා. මතකද learning rate එක මදි නම් තමයි අර විදිය දෙපැත්තට පැන පැන ඉන්නේ. Let's use Adam. Let's see the results now. See the difference. Can you see the difference? No fluctuations, right? There are, but not compared to the SGD, right? So what's the difference? I mean, the Adam optimizer, right? So it's adjusting the learning rate accordingly, right? So can you see now this? This is why I told this is quite interesting thing to like visualize with the theories, right? So if you take like the what you call the error with the weight, right? So now it's like depending on the position, right? So it's adjusting the learning rate, right? So it's like when you are coming to here, it's like slowly reducing the learning rate to reach this kind of a point. Right? Can you see? Now these are the beauty, right, of these algorithms, and now this is what I'm talking about, right? So we have like, so I made only one change. I didn't change the neural network architecture. I just changed the optimizer. Right, so it's giving this kind of accuracy. Now that's why I always mention this is something with trial and error. You have to not trial and error. This is something like you have to implement and test the results. I can't say okay, Adam is going to work for everything. No, it's like not like that. But most of the time it will work. right? So you can see a small adjustment will give a different result, right? So what I mean, you can change the neural network architecture and see. You can change the other activation functions, right? So you can use, instead of ReLU, you can use some other thing, right? Let's say use sigmoid. We can't say what happens, right? We can't say it. We don't know, right? But some obvious things are there. It's better. The Academy is better than SGD, since it's like adjusting its learning rate according to the situation, right? So yeah, it's good, right? I'm not sure. I didn't keep the track about the loss values, right? Or you have like compare it, right? අරගේ loss එක කීය තිබ්බ කියලා මට අරකේ කලින් එකේ මතක නැහැ loss එක අවසාන loss එක කීයද තිබ්බ අවසානයේ poke එකේ කියලා. Right? But you have to check those things. Now, this is what I mean. This is the beauty of learning, deep learning, and neural networks. You have like lots of options. It's like an artist, right? You have like several colors, several brushes, several things, right? So you are the artist, and you can design your own neural network using those tools, use brushes, use paints, right? So you have activation functions, you have neural network architectures, you have optimizers, you have like change those things and build your own optimal neural network, right? So this is like I showed you like few important points, right? So we will discuss about more things in future, right? So but keep these things in your mind, right? So now what you have to do, like train these neural networks architectures and see the results, right? See the results and keep, I mean, try to implement more. I mean, try to get a better results, right? So what you can do, you can always keep a track on the last thing that you are going, last loss. So that's the optimal loss that you are, I mean, the last loss, compare it with the others. So finally, I will change it back to the ReLU, right? And let me run it again. And what I want to do is now I want to check the testing results, right? We can do it using model.evaluate. Model.evaluate. We can apply test data and test target. Test data and test target, right? So what it's going to do, so what it's going to do, like, right? So we know that, right? So we know that train data, right? And train target. We are going to train using train data and train target, right? So what this model.evaluate is going to do, right? This term is going to like add the test data, right? It's going to add the test data, and from here it's going to get like the predicted, right? So the predicted predicted targets. Neural network and predict කරන targets ටික මෙයා ගන්නවා, right? Neural network and predict කරන targets ටික ගන්නවා. So take the predicted target from the neural network and compare it with like it's going to compare it with test target. Test target එක compare කරනවා. Test targets with predicted targets with. Predicted targets. දෙක compare කරනවා. Right? Test target and predicted targets දෙක compare කරලා loss එකයි accuracy එකයි අපිට දෙනවා. මේක මේ වගේ හරියට. Well, past papers වලින් train වෙනවා. You are going to like train from the past papers. And in the exam, right, so you are going to get questions, speeches, and you are going to give the predicted answers. Predicted answers was the what? The answers in the marking scheme, actual answers. Those will be compared and get the accuracy. Key and key right? Get the accuracy, right? Number of correct predictions, right? And take the loss as well, right? So that's what we are going to do here, right? So it's like giving 1% of accuracy, sorry, 100% accuracy and loss of 0.06. Again, 15 15ම හරි. 15ක් නෙයි. 10ක් කියන්නේ 150යි, right? 10% from 150 is 50, right? Okay. Now we can like get the predicted targets from here. Predicted targets. Predicted target model dot predict. Model dot predict. Model dot predict. We are going to like yeah. I බලමු මේ predicted targets වල මොනවද එන්නේ කියලා බලමු test data, right? Test data දාලා I'm going to take the predicted targets, right? Okay. Let me print the actual target. Test target. Test target වල තමයි actual targets ටික තියෙන්නේ. Test target. Right? And let me print the predicted targets. Right? So can you see? 0, 1, 0. 0, 1, 0. That means it's the Fetosa virginica, right? So it's a virginica. So this is the actual target and this is the predicted target. මතකද මම කිව්වා predicted target කවදාවත් අර විදිහට එන්නේ නැහැ. Right? 94%. 0.94 තමයි කියලා තියෙන්නේ. හැබැයි අපි maximum එක ගත්තාම මේක 10 ඍණ එක 10 to the minus 1. This is 10 to the minus 2. This is 10 to the minus 7. So this is the highest one. So second one 0, 0, 1. So you can see the predicted one is 9.9. That means 99%. Right? So I told you like when you are using softmax, it's giving us a probability. Right? It's giving us a probability. Can you see now? Right? So the last one is 0, 1, 1, 1, 0, 0. So it's like giving us a probability like this. Right? So the predicted target, can you see now? This is the predicted results by the neural network. Neural network and then predicted. You can't expect like the neural network is going to give us 0, 1, 0, 1, 0, 0, 0, 0, 1. No, it's going to give us like this kind of values. But if you take the maximum, you can see the result is the same as this. Okay, can you suggest me a method of getting the label out of this? So label is like 0, 1, 2. Making 0, 1, 2 Setosa the virginica the versicolor the කියලා ගන්න පුළුවන් method එකක් කාට හරි මතකද? Label එක 0 the 1 the 2 the කියලා ගන්න. Can you remember method to get the label? I mean මේක දන්නවද අපේ probabilities නේ මට ඕනේ බිංදුවද එකද දෙකද ඒ කියන්නේ මේ කියන්නේ Setosa the virginica the versicolor බිංදුවද එකද දෙකද තුනද කියලා ගන්න. Yes? Can you remember the method? Last week we discussed under NumPy. Label equal np dot can you remember? Can you not this one? Argmax. Axis equals 0. So let me print the label. The NumPy is not defined. Import NumPy as np. Right? What this is? Okay. Argmax. Can you remember the Argmax? Right? So it's going to consider this row. Axis is 1, right? Consider a row and get the maximum column. So what's the maximum column here? This one. So it returns 1. So what's the maximum of this column? 2. So label is versicolor. So here maximum is this one. The label is 0. That means setosa. So we can easily get the label or the label from using the argmax, right? Understood. Using the argmax. Right. Okay. So that's pretty much everything, right? So we have to cover. Now the other thing is that I'm going to provide you another video, right? Similar to this. Not now. I'm not going to take time here. Yes, it's already 9:10. I will provide you a recorded video, right? A recorded video on how to build up a neural network to this is implemented for a simple neural network, right? I will provide you a pre-recorded video, like let's say 20 minutes or 30 minutes, which explains you how to apply apply a data set, a handwritten digits data set, the MNIST handwritten digits data set. Right? So this data set. Sorry, this is the original one. Right? So this data set, we have a data set like this handwritten digits. So these are like 28 by 28 images, right? 28 by 28 images. So I will explain how to develop a feed forward type neural network to analyze handwritten digits. I will upload it to the website as a pre-recorded video, since it like take 20-30 minutes if I'm going to continue it here, right? So I will upload it here. So please go through this. I will upload it today itself. අද මම එක අප්ලෝඩ් කරන්න handwritten මේ වගේම similar neural network. I'm going to build a similar neural network for like handwritten digit recognition, right? It's kind of a tutorial thing where you can watch it later. So please watch it, right, and try to implement that as well. And other than that, you are going to get assignment as well today. You had I'm going to provide you a custom data set where you had like provide your own neural network architecture. So that will be also uploaded today, the assignment number 2. But there will be a tutorial. So this is a separate thing where I'm going to like discuss similar kind of a neural network to like handwritten digit recognition, right? So that will be done similarly today as well, right? Okay. Yes. So with that, I can conclude the session for today. But before that, if you have any issues, any concern related to things that we covered today, please mention them. Please ask if there's anything, please. Okay, so before you are coming on to the Saturday session, you have to do several things, right? So please go through these codes and try to like change everything and see the loss functions, the activation functions and other stuff, the neural network architecture. You can add more hidden layers and you can do experiments, right? So do these things and come to your own conclusions, right? So try to like see what's going to happen, but note that it's not applicable for everything. It will be applicable for the iris flower dataset, but sometimes the like some other activation functions would be for other problems as well, other implementations, right? So it's not unique, but you can do it for these applications and find your optimal neural network architecture with the optimal activation functions and optimal set of optimizers, right? And I will provide again a pre-recorded video with like less than half an hour, where you can implement a feed-forward neural network for handwritten digit recognition. So quite important. It will be a small video. I'm going to like use the same kind of concepts and implement it for handwritten digit. And other than that, you have the assignment will be uploaded today itself, where you have like implement a neural network on your own for a customized data set given in a CSV file, right? So that's the work for this week. And again, if you have any questions, please raise them now. Otherwise, I will conclude the session for today. Right. So please go through these videos again and again. Right. So anyway, find the time to do these things. Right. Otherwise, it's a like a wastage of your money, time, and your 12 weeks. Right. So you have to go through these things again. Otherwise, no use of doing this thing. Right. Yes. Again, any issues? Yes, I will provide the Iris CSV file and everything, the codes, the handwritten note, and everything will be provided. Okay, so then thank you very much, everyone, and have a good night. And please do the necessary implementations for this week, right? So please follow the instructions given by me and the codes and the theories and the videos and everything, right? So make a passion in you for this field, right? Thank you very much, and meet you on Saturday with the convolutional neural networks. Thank you.